Hi everyone, welcome to the next video in our series. Now, we're continuing on with this idea of sketching parabolas. Now in the previous video we looked at sketching these via completing the square, and in this video we're going to look at this via the discriminant, which we talked about in the previous series on quadratic expressions and equations, as well as the quadratic formula, which we also talked about. Now, as we mentioned before, just to review some concepts, our first thing here, ax squared plus bx plus c equals 0. This is our general form of all quadratic equations. And this guy here, this gives us the solutions to our quadratic equation. Now, we looked at before that sometimes this can be two solutions, sometimes one solution, sometimes none. Now this plus minus thing ends up being quite important, especially when we have two solutions. But this guy here is what we call the quadratic formula. And a special part of the quadratic formula is this guy in here. This is what we called the discriminant. And this thing here, you may remember, we use this to determine a lot of important things about our parabolas. So mainly the amount of solutions that they will have, whether this is none, one, or two. Now, we know all of these ideas pretty well, hopefully by now, and we're just going to jump straight into using this stuff in order to sketch some parabolas and use these particular techniques in order to do the same thing we've been doing in the last video. So calculate the turning point, calculate the y-intercept, calculate the x-intercept. Now, really quickly, before we move on, I just want to talk about something really interesting here, which is this idea of the turning point. Now, in the previous video, I think it was, we had an example where we had an x-intercept of -1 and an x-intercept of 3, and we had a parabola going through these two. Now, I just want to bring your attention to something that we didn't talk about last video, but is actually quite important. Now, if we consider this turning point, notice where the x-coordinate of this turning point, let's call it xy, is in relation to these two x-intercepts of -1 and 3. I don't know about you guys, but to me, this looks like it is falling roughly in between the two. So in, I think, one of the videos before, we don't have to worry about the y-coordinate of this for now, but we had an intercept of 1. Here. Now, if we measure, for example, the distance from my first x-intercept, my first solution to my quadratic equation, this is 2 units away from 1, and this guy over here was also 2 units away from 1. So the axis of symmetry is right in the middle of my two x-intercepts. And what lies on this axis of symmetry here is my turning point at the minimum point here. So the x-coordinate of my turning point is going to be the middle of -1 and 3. Now, what's another thing we've looked at before when we looked at this idea of the middle? Well, one thing that tells us about the middle, if we revisit what we looked at in statistics, the middle / average is going to be two numbers added together and then divided by the number of numbers we have there. So here we have two numbers, -1 and 3. We're going to add those together and divide it by 2, because there are 2 numbers here. And when we average this out, we're going to get minus 1 plus 3 equals 2, divided by 2 equals 2, and the answer is 1. So here, my x coordinate of my turning point is the average of the two x-intercepts. This is a very important idea because when you look into your textbooks, you'll be given this really mysterious formula when you start talking about turning points using the quadratic equation and the discriminant. Now, you will be given something that says for the turning point, x equals to minus b on 2a. And I don't know about you guys when you've seen this in your textbooks, maybe this is your first time seeing it, but this to me looked very puzzling the first time I came across it. I found it really weird and it was never really explained to me how we get to this thing in the first place. So this is where I'm going to take a moment to consider this idea. Conduct a little investigation into this idea of the x-coordinate of the turning points. Of the turning point, I should say. Now, to do this, we are going to be using this idea of averaging things out. Now, if you don't care about this part, feel free to skip through. This is just for the people that are interested. We're going to run a little investigation into why the x-coordinate of the turning point is given by this negative b over 2a. Now, we are going to draw my set of axes. So I have my y-axis and my x-axis. And I'm just going to draw any old parabola. And via the quadratic equation, when we have, for example, two solutions, 1 and 2, then we are using both, if we go back up to my quadratic formula, minus b plus the square root of b squared minus 4ac over 2a, as well as minus b minus the square root of b squared minus 4ac over 2a. These are going to be the two turning points. So I'm going to write that here. My first turning point here, let's say that's minus b minus the square root of b squared minus 4ac all over 2a. And this guy here is the other solution. So minus b plus the square root of b squared minus 4ac over 2a. Now, we noticed before that the x-coordinate of the turning point is the average of the two x-intercepts. So, I have my first and second x-intercept. So to find the turning point, that's going to be this first equation, well, this first value of x, plus my second value of x, these are my intercepts, divided by 2, divided by the amount of terms I have. That's how averaging works. Okay, now what we're going to do is we're just going to add these two together. So I'm going to take, and this is going to look very messy, so please forgive me if this looks a bit shocking, but I'm going to have minus b minus the square root of b squared minus 4ac over 2a plus minus b plus the square root of b squared minus 4ac all over 2a. And this whole thing, we're going to do that later, but this guy here, we have to divide by 2 because we are averaging this out. So let's do the addition here first. I'm going to add this term to this term, and notice they have the same denominators. So I can just leave these as a fraction over 2a and add the numerators together. Now here I'm going to get minus b minus b squared minus 4ac plus minus b plus the square root of b squared minus 4ac, all over 2a. Okay, now if we expand this thing here, I've just put the brackets in order to avoid confusion, but this plus minus b is going to be the same as doing minus b. So this is the same as saying minus b, and I had two positives, so I'm going to be plussing b squared minus 4ac. Now notice that this term here, this negative b squared minus 4ac, negative square root of b squared minus 4ac, is exactly the same as this one. One of them's positive, one of them's negative. So these two are going to cancel each other out. So here I'm going to get minus b on the top. That gives me minus 2b over 2a. And this thing, these two are going to cancel out. That gives me minus b on a. But remember, we still have to divide by 2 here. So we've simplified this thing up here. Now we just need to divide by 2. So minus b over a divided by 2 is the same as minus b over a times a half. Because remember, dividing by a number is the same as multiplying by the reciprocal. And that gives us minus b over 2a. So this is how we can understand this idea of finding the turning point. So therefore, the x-coordinate of my turning point, using the quadratic formula, I can get this by doing x equals minus b on 2a. So let's actually end this video here. We'll break it up into 2 parts, but this was more of an investigative video in order to give you the sense of how to find an expression for the x-coordinate of this turning point. And then substituting whatever that is into my quadratic equation will give me the y. But this I get from doing minus b over 2a. And then my y-coordinate is just whatever I get when I substitute this back into my original quadratic equation. Y equals something. But that brings us to the end of part 1 of this video, and I will see you in part 2, in which we will look at applying this to some actual questions and doing a bit of curve sketching. Thank you so much for joining me, and I'll see you next time.